Hi guys, yeah, welcome back to my channel. Today we want to look at atomic structure and bonding. As a JAMB out there, I promise you guys I'll be depositing video on each of the topics and the kind of question you come across in your JAMB examination. So today we want to take a look at atomic structure and bonding. The first question goes thus: the bond that's likely to be formed between element X with electronic configuration 282 and Y with electronic configuration 286 is A. Ionic bond, B. Dative bond, C. Metallic bond, D. Covalent bond. This is JAMB 28 equation number what? 28. So I told you guys that we are not here to just pick answer for you. We are here to tell you guys why A is A, why B is B, why C and D is D. So we are not just picking answer without explaining. So let's take a look at what we have on the board. They said element X. Element X is given to be 282. Are you with me? Element Y is given to be 286. As a JAMB out there, how do we know this kind of element and how do we come across the kind of bond that exists in this kind of what? Question is very simple. So the only thing you can just do is that by writing out the electronic configuration or by showing the shell of each of the elements on the board. The first thing is, if you are given something like this, the first thing I will advise you as a JAMB is that learn to identify the elements. So this now is 2 plus 8 is 10 plus 2 is what? 12. So when you look at the first 20 elements, the element with atomic number 12 is magnesium. And the next one is 2 plus 8, we have 10, plus 6, we have 16. And the element with 16 is what, class? Sulfur. So we have 16 here. And here we have what here? 12. So if we are to get your answer correctly, it is very simple. And when you look at chemical bonding, for you to know more about bonding, you need to have a concept of what we call the electronic configuration. So check in my video catalog, you'll find some video which will be helpful for you. So guys, what is the outer electron here? This, which is this. We have 1, 2. What is the outer electron here? We have 6. 1, 2, 3, 4, 5, 6. And when we talk about bonding, we have two main types of bonding. The first one is ionic bonding or electrovalent bond, while the second one is covalent bonding. We have other types of bonding which are dative covalent bond or coordinate covalency. We also have what we call the hydrogen bonding, as well as metallic bonding and van der Waals force. So now let's check the kind of bond here. So guys, if we are to look at this now, we need to understand the concept of duplets and octets. An octet states that the outer electron of each of the elements must have what? 8 electrons. And the formula goes thus: we have NS2 and NPC. So when you add 2 plus 6, we are having what? 8, which is this. That's for octet. So now guys, looking at this kind of the structure now, sulfur need 2 electron to attain its own octet states, and by doing that, when you have this kind of arrow, it is called the transferring of electron from a metal to a non-metal. And by doing that, the metal is always the donor, while the non-metal is always the what? The acceptor. So guys, magnesium is acting like is helping sulfur to attain its own octet state. So guys, sulfur needs just 2 electrons to attain its own octet state, while magnesium needs 6 electrons to attain its own what? Octet state. So when you look at the number and the values, you can see that it is 2 that is close. When you add 2 to 6, you have what? 8. The same thing when you add 6 to 2, you will have 8. But the number which is closer to 8 is what? 2. So magnesium is donating a 2 outer electron to what? Sulfur. So with that, we are going to write this now by saying we have, for magnesium, we have 2 8 instead of what? 2 H2. Why? Because magnesium has donate a 2 outer electron. Why this will be having what? 2 8 8, because sulfur has what? Accept 2 electron. So guys, note one thing: any element that donates are called the donor, which is the what? The metal. The one that accepts, so we call them acceptor, they are called the non-metals. Please take note of that. So class, when we look at option A is ionic bond. When we talk about ionic bond, we are talking about the transfer of electron from a metal to a non-metal, which A goes with the answer. B, when we talk about dative covalent bond, dative covalent bond deals with when two elements come together to share electron, but a lone pair is left out there. Why for metallic bond, they are closely packed together. For our covalent bond, it deals with the sharing of electron from one element to another, or with the same element. So guys, don't worry, just focus on the videos. I'll be showing you guys some questions which are related to the options. So guys, as I've said earlier, that the transfer of electron from a metal to a non-metals are called ionic bond or electrovalent bond. The answer is what? A. Are you with me now? So 2, water molecules are added together by A, covalent bond, B, ionic bond, C, hydrogen bond, D, van der Waals force. When you look at all these first options here, van der Waals force is one of the weakest. It is very weak among all. So now, how do we know the one that is held together? Covalent bond deals with sharing of electron. I can have this water now. Let's see, water molecule. So let's draw the structure and see the kind of what bond that exists. Oxygen will act as the central atom. We have one hydrogen here, another hydrogen here. So let's go. The outer electron of oxygen is 6. 1, 2. So one hydrogen like this, one hydrogen like this. So now, guys, we have lone pair, and we have bond pair. Again, lone pair, and what? Bond pair. When you look at this kind of question now, this place is called the lone pair. And what they ask you is that water molecules are held together. They did not ask you that what is a kind of bond that exists. The question goes to us, water molecules are held together by what? So when we look at this now, water molecules are held together by hydrogen bond, because, listen attentively to it, water molecules are what? Held together by hydrogen bond because hydrogen has the highest priority, and moreover oxygen fall under the electronegative elements. But with the increasing and descending order of the arrangement of the elements under the electronegativity, oxygen falls under it, which makes it have the what? Hydrogen has the highest priority to attract or to add water together, and with that it gives water the highest priority to have the, we call it, high boiling point despite its low molecular mass. So the answer is what? Hydrogen bond. So we take a look at some other question under this atomic structure and bonding. There are some questions here which are the JAMB always play with it every year. So let's take a look at that too. Let's take a look at that. Okay, this is 2018. said earlier, JAMB 2018 question 10. So let's take a look at another question similar to that. This JAMB 2019 question 28. For those of you that want to practice, so number 5. Okay, this one too is a good question. In ammonia molecule, the number of non-bonding electron A, B, ID we have one. This is question 3, JAMB 2021. Let me see if I can find a question related to that also. Okay, look at this. The bond that exists in oxonium this question is likely question that JAMB always play with. C, in D, so guys, let's go class. They said the maximum number of electrons that p orbital can accommodate is A6, B14, C10, D. So class, when we look at this maximum number of electron, the only thing I can easily tell you guys is that, look at this. I'll relate this question here to what we have here. This is it. We have S orbital, we have P orbital, we have D orbital, and we have F orbital. Are you with me now? So S orbital has this degenerate orbital, which is zero-fold. Again, S orbital has this, which is zero-fold. P has this, which is three-fold. This 1 2 3 4 1 2 3 4 5. So now it means that this S here can contain what? 2 electrons, 1 to 2 electrons. These can contain 1 to 6 electrons. These 1 to 10 electrons. Wipe this off. 1 2 3 4 5 6 7. This can contain 1 to 14 electrons. So guys, look at this now. They say the maximum number of electrons that p orbital can accommodate is what? What you have on the board here has explained it all. So you can see now they have 6 electrons, 14 electrons, 10 electrons, and what? 2 electrons, and which everything is in what? On the board. Just what I was saying, he said you can clean this, can contain 2, this 10, and this what? 14. Are you with me now? So our answer is what? For p orbital contain what? 6 electrons. Our answer is what? A. So now let's easily relate what we have here to this. They said which of the following has 0-fold degeneracy. So now you can see now these 2 electrons, this degenerate orbital for S here, we can easily relate it to what? 0-fold. How? Because I have this. Are you with me now? If I should have one here, are you with me? I have another S orbital. I have 1, I have 2. How do we have 0-fold? Because electron, the number of electron is different from the degenerate fold. The number of electron this S can contain is what? 1, 1, 2. So S, according to the maximum number of electron, the arrangement, their fold, S can contain 0-fold. Are you with me now? Our P, 3-fold. D, 5. That one is 7-fold, which is off. So our answer is what? S. Number 5. In ammonia, the number of non-bonding electrons. JAMB would like to twist your brain. That meaning of that non-bonding is the same thing as lone pair. And lone pair means that those electrons that they are not reacting or bonding with other elements. So now let's take a look at this now. Ammonia is NH3. The central atom is what? Nitrogen, which is this. Then how many hydrogen do we have here? We have 3. You can say we have 1, 2, 3. Are you with me now? So when you look at this now, what is the outer electron of what? Nitrogen. The atomic number is 7. So the outer electron will be what? 5. So let's go. We have 1, 2, 3, 4, 5. So looking at what you have on the board now, okay, this one go for hydrogen, hydrogen, hydrogen. So the non-bonding is this. Non-bonding, or you call it lone pair. So how many non-bonding do you have here? You can see now, if that when this one combined to this is bond, this combined to this, so the non-bonding is what class? 1, 2, which is this. B is the answer. The last question. The bond that exists in oxonium ions are covalent and dative. B, covalent and ionic. Dative and ionic. When we talk about oxonium, if you have water plus hydrogen ion, you know we have what? This hydrozonium ion. And look at this now. This explanation. Covalent bond exists in water, while in hydrozonium dative bond exists, because the exchange of electron here, and here we are having a lone pair here. And I told you guys earlier when I was doing the first question that if you are given a question where you have a lone pair, you can easily be, it involves the sharing, and lone pair is involved there, or non-bonding is involved there. They are easily classified as is it a dative bond or coordinate covalency. So guys, water here, covalent bond exists in water, while in hydrozonium ion dative bond exists. So our answer is what? A. So guys, don't forget to subscribe to my channel, like, share among your friends who are preparing for JAMB out there, and do yourself good by dropping those questions you're having issues with. Thanks.